Okay, you know this the one to given you more understanding, easier than the lab 30. That's the thing that we're talking about. U4 82 55. That's a PIO, input output. Okay, program able. You understand in the part, the computer will be 8-bit data. Okay, on the 8-bit. However, when they want to using the computer to test the circuit board, they need more than 8-bit. They can get up to 24-bit or 16-bit or 72-bit. So that's why they get a design for 8255. Now, try to see how this works. Basically, this is just a buffer. Whatever you're writing in, they come in. And you can verify output from U2. Okay? Make sure pin 1 and 19 must be 0. Pin 1 and 19 basically coming from U3. You see, U3 here is a decoder. Depending on ABC, if you get a 0, 0, 0, pin 15 will be 0. The rest have to be 1. They work in the same like decoder 74139 on the lab 30. Only thing is 74139, they divide into 2 IC. They combine 1 IC. Okay, depending on ABC, only one output will be low. Okay? And now, this is 8-bit for U4. D0, D1, D2, D7. So this IC, you can let 8-bit go to port A, or go to port B, or go to port C. So that will be telling you, 8-bit you can go to 24-bit parallel. If you need more, adding one more, then you can get 48-bit. Okay? And basically, this U4 will be controlled by software inside. If you see they get a read, they get a write, A0, A1. A0, A1, that's a very simple. 4 combination, 0, 0, 0, 1, 1, 0, 1, 1. So if 0, 0, that means you want port A. 0, 1, you want port B. Okay? 1, 0, you want port C. Okay? And you can program U4 for data going out or data coming in. That means they can bi-directional. Same thing for B and same thing for C. That's a general information for 8255. If you get any question, just let me know. Okay. Now, only thing here, I get a little error here. You can see U14. We don't have a U14. That must be U13. They will be going to up here. Right here. U13. Okay, not 14. That is error. So basically, U5, you already know. Memory. You want to apply memory. You need to apply a address. You need to apply the data. Data will be go U4 pin 10. U4 pin 18. That means port B go to data. So you can apply send data to port A for address. You can send data to memory to port B. Then you can apply write data. Okay? So if you're looking at the way we're using for connector, both sides, that means they can going out or they can going in. Port C here, only one side going in. That means port C will be read data only. Port A will be going out only. So you can see that's a very simple to test the memory. Better than the lab 30. And the data from memory go to U7 and go to DA converter. That means here. Okay? This is identical to the lab 30. This one the same thing, identical. Okay, now today I want to talk to you about the IC 8255. Here, you don't have a dead one. I will be update later on. They said, if you want to know about 8255, then you can go to the Google and type it, okay? Now, I go Google. I'm going to copy that one. Let's see, pattern. Okay, so you can get into IC made by Intel 8255. Okay, you can read whatever here. Okay, now this just telling you block diagram inside the IC. Okay, we don't care about that. Okay, let's see. Now, this is the one. You need to look into that. basic operation. Okay, you can see A0, A1, 0, 0. That is port A. Write equal 1. So basically, they will be write data to the output. That's what they call a data bus. And the next one, you change 0, 1. Now they're talking about B. 1, 0, port C. So that means you want to send data out up to 4. Then you have to follow that format. Okay? You get any questions, just let me know.
Hey, Mr. Pham, the one on top, it says input operation read, and then the second one says output operation write.
Yeah, the date is right. Date will be read. Let's see. They said port A to data bus. Okay, now, sorry. That will be read. I give it to you, that thing here. If you're looking on ICU4 here, which one is a data bus? What pin is a data bus? You need to talk to me for your understand. You're looking at U4. If
Well,
in
you mean
the,
like that?
in the data, they say data bus. I want to know where is the data bus? That's what they're talking about.
Are you talking about the 8-bit lines, like 4, 3, 2, 1, 40, 39, 38, 37?
Exactly. That's right here.
Right. So,
That's what they're talking about, data bus.
right.
So A to data bus, that means you read. Okay? That means you get data from here, go into here. That means you're reading port A.
And pin 5's got to be 1, right? U4 pin 5.
U4
Pin 5.
pin 5. Okay, have to be 0.
0. Okay. 0.
Read to see the bar over.
Right. Okay.
Low.
0. Active low.
Pin 1 must be 1. Pin here, pin 36. Must be 1.
1.
You either read or write, you cannot do both.
Right.
Okay? So if you set a 0, 1, A0, A1 will be 0, 0. That means they allow data from port A go here. And they can go to Q2 for verify. And now, if you change A0, A1 to 0, 1, that means they're talking about port B. They can go this way. And if you set 1, 0, that means port C go this way. Okay? That is the read operation. Now, if you want to write the data to port A, then read must be 1. Write must be 0. And they will be do the same thing. If A0, A1, 0, 0, that means you write to port A. 0, 1, you write to port B. 1, 0, you write to port C. Therefore, do operation, read or write. And port A, B, C will be defined by A0 and A1. Any question? Anything? You can see this is very easy. Now,
Hey, Mr. Pham, one thing, maybe, well, no, go ahead.
okay, they're telling you dry operation. You see that? Right now will be 0. Read must be 1. They say data birth go port A, data birth B, data birth go to port C. Okay, now, when you read, you get A0, A1, 1, 1. And read at the 1. Okay? That means they're telling you data birth go to control. Try to understand. Who know what that means? Data birth go to control. That means they not go out A, B, C, okay? They go to control. Okay, if you don't know, I'm telling you. Before you want to using port A, B, C for read or write, you have to write the data to inside the U4, telling them, okay, you want A out, B in, C out, whatever. That's what you set it up inside the IC.
Oh, I know.
So they know what to do.
Oh, so Mr. Pham, so you talking about, like in the past, you had something called like 0x98 or something, and I don't remember exact.
89.
89, yeah. So it tells you which way A, B, and C will go. It might say A go and B go out and half of C go in and out.
That means you set up inside the IC. So
that's called control word?
Yeah, that's what they call a control word. That's only thing. You need that. You can see chip select, they must be 0. However, if they add logic 1, data birth go to high impedance or three state. Okay? Normally, if you're not using the IC, port A, B input, data birth, they will be tri-state. Okay? That means too many things for you to read, but basically we don't care that. I'm telling you what we need. It's just a pin number. Now, this is the one. You see that? They're giving you control birth here. 8-bit. What the data here? 0,
80. 80.
So if you write the control data 80, That means you will be set 8-bit port A go out, 4-bit port C go out, 4-bit C go out, and 8-bit B going out. So basically you want which output going out, which output going in. You need that control word. Okay?
So basically, Mr. Pham, you have to scroll down to 0x89, and that's the one you was talking about.
Yeah. Let's see. 8-9.
That's it right there.
Right here.
Right here, yeah.
You see that? 1 0 0 0 mean 8. 1 0 0 1 mean 89. 89 will program to make sure port A going out. Okay? And port B going out. And port C going in. That's 89. So if you want to set which ports out in, you have to go through this table to find out. Okay? See that? On this one, they will be 8A, right?
Right.
Then port A go out, 8-bit. Port C, 4-bit go in, 4-bit go out. Port B, 8-bit go in. So depending on which port you want in or out, just using that control word in here. Okay? So that's the only thing we need to know. Just wait for me. I get the program. Oh, in here. Maybe in here. Let's see. You see in the sample here. You see that ADC 10, 14. We have to write control words 89. That means you want what? A going out, 8-bit. B going out, 8-bit. C going in, 8-bit for this 10. Okay?
Line 235, Mr. Pham.
Right here.
Yeah.
Okay. Write the control word 8A. Okay. 8A. Then we're looking for 8A.
right there.
Right here. 8A. You want 8-bit A going out. Okay. So basically, port C, 4-bit coming in, 4-bit coming out, and 8-bit B coming in. So basically, depending on you want port ABC to be output or to be input, then you can look into this table. Okay, and you can write a control.
And Mr. Pham, a question on that one.
Yeah,
Like, if you're writing, you could use A, port A. 8 bits on port A going out for writing.
yeah,
Okay, and then port C is half writing and half reading because 4 bits is going in.
yeah, 4 in,
4
4
in and
out.
4 out. And
However, on that part memory, we're using only A and B.
well, B is going in, so you can't write the B, right?
Right, you read it.
You can only read B.
Yeah,
But A, you write on A and read on B.
right.
And what about C?
We don't care.
It's half and half.
Yeah, but we don't care. We're not using port C on that.
Oh, okay, I see what you're saying. You're only using A and B on this one.
Right, exactly.
Okay.
So basically, you now understand this thing. Then you can make the 8255 working. And the other thing here, if you engineer it, then you can go into the detail inside that IC. Okay, they can do a lot of different timing. That for engineering. For technician, only thing we need to understand between the input and the output. We don't care what inside the IC. Okay, so any more question? Otherwise, we'll see what's going on. I don't know. It's hard to tell you.
But we log on regularly like we normally do on Monday, right, Mr. Pham?
Exactly, that's just normal.
Okay,
Okay, so any more questions?
thank you.
You're welcome.
Good night.
Good night, everyone.